Alrighty, today we're going to be moving on to covalent bonding in ionic compounds. So what happens though if the electrons aren't given but are instead shared between elements? So ionic bonds occur when electrons from a metal are donated, the metal becomes a cation, and a nonmetal in turn accepts the electrons, the nonmetal becomes an anion. Sometimes, however, electrons are not given and accepted, but rather shared between elements. These types of bonds are called covalent bonds, and they occur between nonmetal and nonmetal elements. So whenever a compound is made by sharing electrons instead of donating or accepting them, it's a covalent bond and occurs between two nonmetals. Like ionic bonding, covalent bonding occurs in order to help two elements to gain a full valent shell. This can occur in the form of a single, double, or triple bond, depending on the situation. So let's break that down a little bit. Single bonds. Single bonds are when one electron from each element in the bond is shared with the other element. So we're sharing one electron from each element in the compound. So for example, if we have hydrogen, which has one valence electron, and chlorine, which has 7, both of them hydrogen needs to gain one electron in order to form its full valent shell of 1s2, but chlorine needs to gain one electron in order to gain its full valent shell of 8. So neither of them wants to lose an electron, they both just want to gain one, so they're actually going to share an electron each. So hydrogen will share its one electron with chlorine. Chlorine will share one of its electrons with hydrogen. And so they're kind of going to share the electrons to make a bond. So then we have a hydrogen and a chlorine, and those two electrons, that red electron from hydrogen and this black electron from chlorine, are shared to make this bond. So what about double bonds then? Sometimes in order to obtain a full valent shell with the given nonmetal elements, the elements need to form double bonds. This happens when two electrons from each element are shared in bonds. So for example, if we have carbon and oxygen atoms have 6 valence electrons, so they need to gain 2 more electrons in order to gain their full octet. Carbon, on the other hand, only has 4 electrons. And so it needs to gain another 4 electrons in order to gain its full octet. So each of those oxygens are going to share their 2 lone electrons with 2 of carbon's electrons to form what we call double bonds. So for example, these 2 electrons are going to form a bond, these 2 electrons are going to form a bond, and this carbon and the left oxygen form 2 double bonds. They're each sharing they form 1 double bond. They're each sharing 2 electrons, 2 here and 2 here, to form 1, 2, it's a double bond. And then over here, these 2 electrons will form a bond, and these 2 electrons will form a bond. And so you'll be forming 2 double bonds. Carbon forms 2 double bonds with 2 different oxygens. And so what you wind up with, when these 2 electrons form a bond, they aren't valence electrons anymore. So oxygen just has 4 valence electrons now. And so it has carbon with 2 double bonds, a double bond here and a double bond here between the oxygens. And that way carbon has 2, 4, 6, 8 electrons, and oxygen has 2, 4, 6, 8 electrons. This oxygen has 2, 4, 6, 8 electrons. And all 3 of those elements then have their full octet, their full valence shell, and they share those electrons together. Triple bonds occur when 2 elements have to share 3 electrons in order to obtain their full valence shell. So for example, nitrogen. Nitrogen has 5 electrons in its valence shell. It needs to gain 3 electrons. Now nitrogen could share, 2 atoms of nitrogen could share their 3 lone electrons and make triple bonds with those, so that each of them gains their full octet by sharing. So these electrons would form a bond, these electrons would form a bond, and these electrons would form a bond, making you would have 2 lone pairs, one here and one here on the nitrogen, which has how nitrogen likes it, and then 1 triple bond right here. So that's how we talk about bonding. We have single, double, and triple bonds. Polarity, an issue of fairness and pole. So when two elements share electrons, one element will attract the electrons more strongly than the other due to a higher electronegativity. So like I said, those periodic table trends actually will come in handy when we're talking about bonding. So if one element has a higher electronegativity, it has a stronger attraction to the electrons, and so it's going to pull them or attract them more strongly than the other element. The element that attracts the electrons more results in a slight negative charge because it's attracting the electrons more to it. Electrons are negative, so it develops a slight negative charge, which means that the element that doesn't attract the electrons as much results in a slight positive charge. This creates what we call a dipole, meaning it has two poles. When you think of a magnet, it has a south pole and a north pole. Well, when we talk about polarity, we're talking about a positive end and a negative end, or a positive pole and a negative pole. If something is dipole, it is a polar compound, and it has, we call them two dipoles. Even though it's just one end and the other end, we call them dipoles. So for example, hydrogen and chlorine, the single bond that we found earlier. Hydrogen has an electron affinity of 2.1, chlorine has one of 2.5. So chlorine is going to attract those electrons more than hydrogen, which means that it's going to have a slight negative charge. That little symbol there that looks like an incomplete 8 is called a delta. It's a lowercase delta. It's like a really curvy D, or like I said, an incomplete 8. And it means slight or slightly. And so if chlorine is slightly negative, hydrogen is slightly positive. So that's something to kind of keep in mind about polarity, is that we can create what we call dipoles, and this creates a polar molecule. So when we talk about polarity of bonds, bonds can have different polarities like you saw based on the electronegativity of the elements involved, and this actually dictates what type of bond is going to be formed. So the polarity of a bond is dependent on the difference between the two electronegativities of the two elements involved. And there are two types of covalent bonds we can have. We can have a polar covalent bond or a non-polar covalent bond. So a polar covalent bond, you can guess, is going to have a difference, a larger difference in electronegativities, and a non-polar is going to have not as large of a difference in electronegativities, because you're not creating that slightly positive end and slightly negative end. So let's look at this. So we have a table here, and this is a table of the types of bonds, comparing them to the electronegativity differences. So for example, if the electronegativity difference between the two atoms that are bonding together is between 0 and 0.4, it's going to be a non-polar covalent bond. So something that is pretty much equally sharing the electrons. So for example, Cl2. Two chlorine atoms are going to bond together. They're going to share the electrons equally, which is why it looks like such an equal electron cloud. They have the same electronegativity because they are the same element, so neither one is going to attract the electrons more or less. For a difference between 0.4 to 2.0, it's going to be a polar covalent bond. So a polar molecule like HCl, which was the example we showed, where hydrogen had a slightly smaller electronegativity than chlorine, and so chlorine attracts more of the electrons than hydrogen. And then if its electron negativity difference greater than 2, greater or equal to 2, it's going to be an ionic bond. If one of them likes the electrons so much more, it's actually going to steal the electrons, and it's going to become an ionic bond where one donates and one accepts electrons. So I have a question to you guys. What type of bond is HF, or hydrofluoric acid? So take a minute and open up your books or Google it, find the electronegativities of hydrogen and fluorine, and calculate what type of bond it's going to be. So please pause the video and do that now. So when you Googled it or looked it up in a table, you should have found that hydrogen's electronegativity is 2.1 and fluorine has an electronegativity of 4.0. When you do that math, 4.0 minus 2.1, you get an electronegativity difference of 1.9. This would fall in the 0.4 to 2.0 range, and it is a polar covalent bond. It's actually a really polar covalent bond. So that would be an incredibly polar molecule where most of the electrons are attracted to the fluorine and only some of them are attracted to the hydrogen. All right, we're going to talk about naming covalent bonds in class. So come prepared and understanding what a covalent bond is, and then we will discuss how to name them and practice some stuff on that. You guys have a great day.